Hi guys, welcome to another amazing video of this chapter. You already know about parallel lines, transversal and the relation between the angles when a transversal intersect parallel lines, right? Let's recapitulate all these concepts. Let's start with a transversal. We know that a line which intersects two or more lines at distinct points is called a transversal. Like here, line L intersects line M at point A and line N at point B. This means line L is a transversal for lines M and N. Now tell me, how many angles are formed by these intersecting lines? Time's up. If you look carefully, you will see that 4 angles are formed at each of the points A and B. Let us name these angles as angle 1, angle 2, angle 3 and so on up to angle 8. Since these 4 angles lie outside the lines M and N, these are called exterior angles. And these 4 angles are called interior angles because they lie in the interior of the two lines M and N. Do you remember there are some special names given to these angles? Let's revise them together. When a transversal intersects two lines, some special angles are formed. They are corresponding angles, alternate interior angles, alternate exterior angles, and interior angles on the same side of transversal. Let's look at each of them one by one. Let's start with corresponding angles. Here, angle 1 and angle 5, angle 2 and angle 6, angle 3 and angle 7, and angle 4 and angle 8 are all corresponding angles. Do you remember how to identify them? Number 1, they should be on the same side of transversal. And number 2, there should be an angle between them. Now it's turn for alternate interior angles. Here, angle 4 and angle 6 are alternate interior angles, and angle 3 and angle 5 are also alternate interior angles. The angles that are formed in the interior of the two lines and on opposite sides of the transversal are called alternate interior angles. Further, many a times we use the words alternate angles for alternate interior angles. Now, alternate exterior angles are formed in the exterior of the two lines and on opposite sides of the transversal. Like here, angle 1 and angle 7 and angle 2 and angle 8 are pairs of alternate exterior angles. Lastly, interior angles on the same side of the transversal. As the name suggests, these are interior angles which lie on the same side of transversal, like angle 4 and angle 5 and angle 3 and angle 6. Interior angles on the same side of the transversal are also called consecutive interior angles or allied angles or co-interior angles. That was all about 4 types of angles. Now, what if the two lines M and N become parallel? Will there be any effect on these angles? Let us find out the relation between the angles when line M is parallel to line N. We know that lines are parallel if they are always the same distance apart and will never meet. So firstly, draw 2 parallel lines. You know that the ruled lines of your notebook are parallel to each other. So, with a ruler and a pencil, draw 2 parallel lines along any 2 of these lines. And then, draw a transversal to intersect them. Then, name the angles like this. Now let's measure any pair of corresponding angles to find the relation between them. Let's start with angle 1 and angle 5. Both these angles are equal. Let's take angle 4 and angle 8. These 2 angles are also equal. Is it true for all pairs of corresponding angles? Well, if you measure all these angles, you will find that angle 1 is equal to angle 5, angle 2 is equal to angle 6, angle 3 is equal to angle 7 and angle 4 is equal to angle 8. So from this, we can conclude that if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. This is actually an axiom, also known as corresponding angles axiom. Now what if this axiom is flipped? Can we then say that if a transversal intersects two lines such that each pair of corresponding angles is equal, then the two lines are parallel? We very well can. This is true in general. Now what about alternate interior angles? Let's find out. We just saw that angle 1 is equal to angle 5. Also, angle 1 is equal to angle 3. And why? Because these are vertically opposite angles. So, from these two equations, we get angle 3 is equal to angle 5. Similarly, we can get angle 4 is equal to angle 6. So, we just proved that if a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. This is actually a theorem. We used corresponding angles axiom to prove this theorem. In a similar way, using the converse of the corresponding angles axiom, we can prove that if a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. These results are true for alternate exterior angles as well. Now, what can you say about interior angles on the same side of the transversal? Well, we just saw that angle 3 is equal to angle 5. Also, angle 5 plus angle 6 is equal to 180 degrees because they form a linear pair. So, from these two equations, we have angle 3 plus angle 6 is equal to 180 degrees. This means the interior angles on the same side of transversal is supplementary. We can also prove the same for angle 4 and angle 5. This result can be stated as if a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. Conversely, if a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel. So guys, this was all for today. Now let's do a quick recap. A line which intersects two or more lines at distinct points is called a transversal. Lines are parallel if they are always the same distance apart and will never meet. If a transversal intersects two parallel lines, then each pair of corresponding angles is equal. If a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. If a transversal intersects two parallel lines, then each pair of alternate interior angles is equal. If a transversal intersects two lines such that a pair of alternate interior angles is equal, then the two lines are parallel. If a transversal intersects two parallel lines, then each pair of interior angles on the same side of the transversal is supplementary. If a transversal intersects two lines such that a pair of interior angles on the same side of the transversal is supplementary, then the two lines are parallel.